Let's do a different proof by induction. So what we're going to prove is that for any natural number little n, if you add up all of the numbers 1 plus 2 plus 3 through n and square it, that result is actually the same thing as 1 cubed plus 2 cubed all the way through little n cubed. To do a proof by induction, you need 3 steps, and again, I'm under the assumption here that you've seen this before. So the first step is you want to verify that your proof works for the first natural number. This is often called the base case in a proof by induction. So I'm going to say if n equals 1, let me manually check that our proposed formula is valid. Okay, well the left hand side is actually 1 squared, the right hand side is 1 cubed, and we're good because both sides are 1. Then what you say is, okay, I know it's true for the first natural number. Suppose I know it's true for some natural number k. So now suppose 1 plus 2 through k squared satisfies the formula. So 1 plus 2 through k squared is 1 cubed plus 2 cubed through k cubed. I'm going to take this as true, so I'm going to assume this, and then I want to show that if this is true, then it's also true if I were to go up to the next number and do 1 plus 2 through k plus k plus 1 squared. I want that to give me the desired right-hand side. So what I'm going to do is take my left-hand side and go up to the next level. So 1 plus 2 through k, and then I'm going to add the next positive integer, which is k plus 1. And what I'd like to do is do some simplification and conclude that it has the right form to match the right-hand side of the formula. Okay, the best way to proceed here, in my opinion, is to take what's being squared and actually view it as the sum of just 2 numbers squared. So in particular, let me group together the first k terms and then the k plus 1 at the end. And now I have really just something plus something squared, so you can FOIL it if you like. When you do that, the first terms give you 1 plus 2 through k squared, and then the outer and inner terms give you 2 copies of 1 through k times the k plus 1th term, and then lastly k plus 1 squared. Okay, we can do a little bit of simplification here. The very first term, we know a good way to write that from our hypothesis step. So I am assuming that the very first term here is 1 cubed plus 2 cubed through k cubed. And then the middle term, I'm going to use the sum of consecutive integers formula at the top. So that's 2 times the sum of 1 through k times k plus 1. So that's 2 times k plus 1, and then I've replaced the sum of 1 through k with k times k plus 1 divided by 2, so here we're assuming the formula at the very top of the slide. And then the last term is still just k plus 1 squared. Now the first part is great. That looks kind of like the right-hand side that we're looking for, and we want to take the middle term and the final term and simplify that all the way down. What we'd like to see come out of that is k plus 1 cubed. Let's see, you can cancel out the 2, and then notice both terms here have a k plus 1 squared. So if I factor that out, in the final term you get k plus 1 squared factored out, leaves you with the remainder of k plus 1. And then that all together is k plus 1 squared times k plus 1, so you get your desired k plus 1 cubed. At this point, we've proven this formula by induction. So then I would say by induction, for any natural number little n, 1 plus 2 through n squared is the same thing as 1 cubed plus 2 cubed all the way through n cubed.